Good evening. In Chapter 19, we're going to look at the issue of air pollution. As was the case with water pollution, pollution of the air is an unwanted side effect of the fact that we have so many human beings living on our planet, and the fact that over the years, and most recently in the last 100 years, our industrial processes are contributing to that pollution in ways that are accelerating as we become more industrialized and as the world becomes more and more complicated. Our challenge then, as we will see in this chapter, is to understand what is causing air pollution and to begin implementing those processes that will help us to both stop the air pollution as well as hopefully reverse the damage that we've already done. In order to understand air pollution, we need to know something about the air. In this diagram, we see one particularly important peculiarity about the way our atmosphere behaves. Typically, the temperature of the air is always warmest nearest the Earth. This is because the Earth captures solar radiation and holds it within the soil and then slowly liberates it back into the air. However, as you go higher and higher in the atmosphere and get farther and farther away from the Earth, the air gets colder and colder, which is why pilots often have to wear very heavy garb to keep themselves warm unless they're in climate-controlled conditions. However, once you get up into the stratosphere, something unusual happens. The air actually begins to get warmer. And this is because of something called the ozone layer. The ozone layer is a layer of ozone molecules located in the stratosphere, the second layer of air above the Earth after the troposphere. The ozone layer, which is in the stratosphere, is capable of absorbing harmful ultraviolet radiation that is given off by the sun. This UV radiation is the same radiation which you put sunblock on your skin in order to keep from getting sunburn in the summer months or out on the beach. Because the ozone is capable of absorbing the sun's ultraviolet radiation, it uses that radiation to warm the air around it. So as you go up in the stratosphere, the ozone layer is actually heating the air in the stratosphere. And this continues up through the end of the stratosphere, about 30 miles up, when you pass into the next layer of the Earth's atmosphere. One of the major air pollutants that we deal with is called smog. Smog is a word that is a combination of sunlight and fog. And in fact, there are actually two types of smog. The first is known as industrial smog or gray smog. This is the result of the combination of pollutants, primarily from the burning of coal in large power plants, mixing with fog or humid air in the atmosphere and producing this heavy gray material that settles over the atmosphere and contributes to the pollution of that atmosphere. The other type of smog is called photochemical smog. This is one which we may be more familiar with because this is the one that is generated primarily due to the interaction of sunlight with exhaust fumes on both cars and trucks and other vehicles. Photochemical smog or brown smog is the smog that one often sees settled over cities in the early morning. I know when I first came to Chicago back in the mid to late 1970s, I would drive into the city along I-55, and as I drove in, I saw a very heavy brown layer of air settled over the entire city, which was the result of this brown photochemical smog. As we'll see throughout this chapter, atmospheric conditions contribute a lot to how pollution develops and how pollution may be able to be managed. One particularly insidious situation in the atmosphere which contributes to pollution is something called a temperature inversion. Typically, as I said before, the air of the atmosphere is warmest near the Earth because of the fact that the ground and soil hold the heat generated from the sun that strikes it. In the evening, when the air is cooler, the warmth held by the earth is liberated from the earth, and being warm air, it rises. And as it rises, it carries with it any pollution and other airborne materials that would otherwise be detrimental to people, and carries it off into the upper atmosphere. However, under certain temperature conditions, it's possible for a layer of cool air to get trapped below the normally warm air nearest the earth. When this happens, this cool air, which is heavier than the warm air, serves as a barrier to prevent the carrying of pollutants away from the surface of the earth up into the upper atmosphere the way it normally would. When this temperature inversion occurs, the cool air concentrates and holds pollutants closer to the ground, where it can be a significant problem for people who deal with things like asthma or have sensitivities to those pollutants. This is why you will sometimes hear on weather reports weather reporters talking about the fact that there is a temperature inversion in the occurring, and that people with asthma problems should stay indoors. Most people are aware of the fact that the major air pollutants are those that are produced as a result of the internal combustion engine, the one that is used in most vehicles. The major air pollutants that the internal combustion engine puts out are carbon dioxide, nitrogen oxides, and other compounds also known as VOCs, or volatile organic chemicals, or compounds rather. However, many people are not aware of the fact that these primary pollutants, the nitrogen oxides and the VOCs, are actually converted into what are called secondary pollutants as a result of the action of sunlight upon these nitrogen oxides and volatile organic compounds. As a result, a number of secondary pollutants are produced, such as ozone, and this is bad ozone, not like the good ozone that's in our stratosphere, as well as something called PANs and numerous other compounds, including aldehydes, ketones, and ozone molecules. All of these secondary pollutants are just as difficult and potentially harmful as the primary pollutants that are produced initially by the combustion of various, particularly fossil fuels, in both automobiles, as well as the combustion of fossil fuels, primarily coal, in power plants. In addition to producing greenhouse gases like carbon dioxide, coal-fired power plants are also responsible for producing acid rain as a result of their liberation of sulfur oxides and nitrogen oxides, which can combine with water in the atmosphere to form sulfuric acid and nitric acid. These acid rains, sulfuric acid and nitric acid, then fall down on the earth, and because of their acidity, cause damage to the environment. In this slide, we see the impact of acid rain on a number of areas, and you'll note that the greatest acidity, as marked by a decrease in their pH values, the greatest acidity is concentrated in the northeast and surrounding areas, where the majority of coal-fired power plants currently exist and are used for the purpose of producing electricity. This is a result of the fact that these plants were built in the Northeast a number of years ago, before other technologies were available, and also to take advantage of the fact that there are very high quality coal mines available in the Northeast upon which these power plants can function. In this slide, we see some of the impact and the mechanism of formation of this acid rain. It begins again with the burning of coal within a power plant, and as a result of that burning, gases are given off, which include sulfur dioxide and nitrogen oxides. These combine with water vapor and clouds and produce sulfuric acid and nitric acid, which then rains down onto the surrounding areas. Where this acid rain strikes trees and foliage, its acidity will eat through the leaves and, in extreme cases, will defoliate the trees and eventually kill them. Other acid rain falls into various marine habitats, and again, if the acidity gets to be too great, it can actually cause the poisoning of life within those marine habitats. And interestingly enough, which I'm surprised we haven't seen it already in Chicago, acid rain can actually in the winter freeze and become acid snow, which, like acid rain, can also destroy both living plants, particularly by clinging to them as snow, as well as leach into the ground and cause damage to the various minerals and other important nutrients necessary for the growth of plants. So acid rain is a very insidious pollutant which is all around us, and until we come up with more efficient and less expensive ways of creating electricity, is probably one that's going to be around with us for a long time until we get away from coal-fired power plants as a major source of generating electricity in the United States.